Hey guys, welcome to yet another video on static electricity. We're going to talk about today on electric field lines, okay? Let me just give you a quick scenario. Okay, let's say if I were to have a positive charge here, and if I place small blue positive charges, the ones in blue, place small positive charges around a positive charge, what do you think will happen? You're right. Okay, boom, I will see repulsion, right? Because in our previous videos, we learned that light charges will repel, correct? So you see repulsion here. Okay, so this actually forms the basis of electric field lines. Okay, so for electric field lines of a positive charge, you can see if I were to place small positive charges around it, it will be repelled. So that's basically the direction of the electric field lines. In other words, the direction of an electric field is the direction of force that would act on a small positive charge, all these small ones here. Okay, so okay, just to recap, if I were to have a positive charge, I just place positive charges around. What's going to happen? It will be repelled. So that's why electric field lines of a positive charge actually goes away out of a positive charge. Okay, what about negative charge? Negative charge, if I place positive charges near negative charge, what happens? It will get attracted, right? So that's why positive charge, the direction of a negative charge, the electric field line will go into it. Okay, so positive charge, basically in short, to draw electric field lines, it goes out of a positive charge and it goes into negative charge. Okay, so now that I have a positive and a negative charge, so what happens when both of them interact with each other if I place it both near to each other? Okay, you can see this one, it goes out of a positive charge, this field line goes in, goes out, goes in. Oh, it more or less, it will just say, hey, I'm going out. This guy will say, hey, I'm coming in. Come on, join me. So you can actually draw a follow-through line here, right? Okay, what about this particular one? This one is going out, this is going in. You can see, oh, this as it goes out, will it go out all the way? It goes out all the way, then it gets distracted by negative charge, and then see what happens here. This guy will say, hey, come in here. So this guy will go out and, hey, come in. So, okay, let me come in. So you'll come in a little bit, and then, oh, once it reaches here, it will start to bend towards. Okay, same to the bottom one. What about the top one here? It goes up, but it will be attracted by this one, right? So it will tend to want to go in also, right? So same thing to here. And what about this? This one probably won't get affected. You'll just go out. Okay, in other words, okay, what's gonna happen if I got a positive and negative charge together? Boom. Okay, here's what happens. Okay, you have this line gets doesn't get interfered, just goes straight to the negative. But this one, instead of going out, it gets attracted, so it will be diverted back down. This one also diverted back down such that it will join together. Okay, so about the one that's further away, it won't be distracted so much. Okay, just like when you are watching, if you're studying at home, the nearer you are to the TV, you're very near, you'll be very attracted to it, right? But if you're further away, let's say you're in your bedroom studying, okay, probably you got a bed or something, but if you're in the bedroom studying, you will have less distraction from the TV, although still a bit distracted if your little brother is probably watching Power Rangers on TV, okay? So that's how we draw for these two. So basically, in other words, for opposite charges, you can see it sort of gets attracted, right? Okay, what about if they are both like charges? Can you guess now? Okay, as this one goes out, this also goes out. Do you think they will ever join? You in the corner? You are right. It won't join, of course it won't join. These two can't join because this one goes out, this one also goes out. Okay, if I join, the arrows will clash, right? So this one also goes out, this goes out, then you know what's gonna happen? Will it join? No, in fact, the opposite will happen. It will move away from each other. In other words, 3, 2, 1, you ready for this? And boom, this is what happens. Okay, it actually goes out, out, and this one goes out also. You can see, okay? So in other words, like charges, basically you can treat this like something like a lot of rubber bands that is opposing each other, so it's basically will repel each other. Okay, so representing electric field lines. So just to summarize, the strength of electric field is indicated by how close the lines are to one another. For example, this region here, you can see the lines are closer and indicates stronger field than this region here because they are further apart. Okay, just one last one, electric field lines or parallel plates. When I have two parallel plates, you can see in the middle the electric field lines still pass from positive to negative, but over at the edge, what happens? Over at the edge, it actually bulges out a bit. Okay, so yep. Okay, so hope this video, you enjoyed this video. Okay, I'll see you guys in the next.